Hello everyone, my name is Linda Nguyen. I'm a medical doctor at the laser department of the University of Hamburg in Germany, and I'm very excited to share with you our study on in vivo monitoring of laser-assisted delivery of hyaluronic acid in human skin. So these are my disclosures. So as you all know, skin quality boosters are commonly used in clinical practice to improve skin hydration and quality. And here, physicians are injecting small volumes of the SQB into the dermal and subdermal layer of the skin. It's all fine, but the major drawback is are the several bumps for days resulting from the intradermal injection. So we asked ourselves, what about laser-assisted delivery of hyaluronic acid? So we designed a prospective controlled study, which was approved by the local ethics committee, and recruited healthy male and female probants. And on their forearms, we treated or we marked 4 areas. One area was treated with hyaluronic acid only, the other area with CO2 laser only. The third one was with laser and subsequent hyaluronic acid application, and the fourth one was left untreated as a control. And we measured them 30 minutes and 30 days after treatment, and our outcome measure was the comparison of the biodistribution of hyaluronic acid and the influence of the SQB and the cellular metabolism. So we used the multiphoton tomography, and for those of you who are not familiar with the system, it's not very common in clinical practice or in research field. It is a femtosecond infrared laser, which allows us to detect autofluorescence signaling and second harmonic generation, meaning we can visualize cells and pharmaceuticals non-invasively, intravital, and painlessly. So this is how untreated skin looks like under MPT. These are horizontal sectionings. And on the upper row, you see the MPT images, and on the lower row, just skin cubes for orientation. And this is how skin looks like after CO2 laser, and especially in the second image, in the granular layer, you see a broadened intracellular space, meaning there is much more edema happening because of the inflammation after laser treatment. So for the more interesting part, this is how hyaluronic acid looks like under MPT without any pre-staining. You see those orange sparkles only in the corneal layer and a little bit in the granular layer, but not in the deeper layers. And after laser pretreatment, of course, you see much more hyaluronic acid deep down in the dermal layer between the collagen bundles. And the bluish part, this is actually lidocaine cream we applied before treatment just to numb the patient, and we cleansed it thoroughly, but of course there's still some remain in the wrinkles. And another example in the upper row with hyaluronic acid only, and in the lower row with laser pretreatment. So what happens 30 days after treatment? We still could detect hyaluronic acid, not only in the upper parts, but also in the collagen bundles. The second part of our study was to evaluate the metabolic state of cells, and we calculated the mean fluorescence lifetime, which you remember correlates with the metabolic state of cells. And to simplify it, the higher the ratio of bound to free NADH, the higher the inflammatory state of cells is. And these are just a bunch of green cells due to the calculation. But what is interesting here is the number on the upper right corner. You can see 30 minutes after treatment, tau M, meaning the mean fluorescence lifetime, after CO2 laser plus hyaluronic acid and CO2 laser only are very similar. But after 30 days, it decreases with hyaluronic acid much more than it decreases with the CO2 laser, meaning that the hyaluronic acid supports the wound healing process. So in conclusion, the CO2 laser is an effective method to enhance cutaneous uptake of the hyaluronic acid into the deep skin layers, helping with skin hydration and skin quality. And the MPT film proved to be an effective imaging technique to visualize LADD treatments. Thank you very much.